Hi guys, welcome to your Chapter 3, Lesson 1 notes on inequalities and their graphs. By the end of the day, you'll be able to write, graph, and identify solutions of inequalities. Before we talk about inequalities, let's talk about equations. When you look at equations, you see that that means equals. Equals means the same. So equations relate quantities that are the same. For example, if you had x equals 3, if you put it on like a balancing scale, and you put x amount of things on the left side and you put 3 things on the right side, those are the same. X and 3 have the same value. They are equal. Okay. Then we slide on over here to inequalities. Hey, they still have that equa in there. Equa meaning equals. However, this in means not. So they are not the same. Inequalities means not equal. So if we had an inequality like x is greater than 3, for example, then if we put x on this side of the scale and we put 3 on the other side, then x would sink down and goes like, because it's heavier, I guess, right? Just goes down like that. That's my new trick I learned. Down like that, okay? Then that's not equal. We say these are inequalities, these are not equal. So today when we talk about solutions of inequalities, we're talking about things that are greater than or less than. Now let's translate them from English into math. If I wanted to write an inequality with all real numbers x, so this x is going to represent all the solutions here that are less than or equal to, so less than is going to go like this way, or equal to, that equals, equal sign, to -7. So we'll start out with our x. X is the thing. So we have x is less than or equal to -7, just like that. And we've got it. Throw back to elementary school days. If you ever remember like the shark mouth thing, or if you have like this little shark guy and he wants to go eat, he wants to eat whatever's bigger, so his mouth always goes to the bigger side. So that means that x is smaller than -7, x is less than -7. Similarly, if we have 6 less than a number k, 6 less than a number k is greater than, this is greater than, it's greater than, and then 13. But guys, we need to break down this 6 less than a number. So notice that less than does not say is less than. So 6 less than a number k is when you have a subtraction, but 6 less than k is k minus 6. So that means k minus 6 is greater than 13. So whatever k is, any number, whatever k is, you subtract 6 from it, that's going to be greater than 13. So we did a throwback to like shark mouth thing. Let's do another throwback to solving equations. Remember when we talked about a solution of an equation is a value that makes the equation true. So whatever we would plug in for, x, here the solution would be 3, right? Because 3 equals 3, that makes it true. Similarly, the solution of an inequality, that's not equal, is any number that makes the inequality true. Now, an equation only has one solution. So an equation has one solution, but an inequality has many. Some of them have infinitely many solutions. There are so many. So let's check. Let's check if we can determine if a number is a solution of this equation. So what we do is we take our number. We want to say, hey, is -3 a solution of 2x plus 1? Well, our first step is we're going to substitute. We're going to plug in -3 in for x. So instead of saying, hey, 2x plus 1 is greater than -3, we're going to take this x and we're going to make it a -3. And everything else is the same. 2 times negative 3 plus 1 is greater than negative 3. And we want to find out, hey, is this true? We're asking. So we're going to put a little question mark there. Well, I mean, just by looking at it, I don't know if it's true or not. I need to reevaluate my life and simplify it a little bit. So that's going to be our second step. After we substituted negative 3 in for x, we're going to simplify. So our first step in simplifying, 2 times negative 3 is negative 6 plus 1. Is that greater than negative 3? Well, negative 6 plus 1 is negative 5. Okay, negative 5 is greater than negative 3, but it's not. So no, this does not make our inequality true. This is not a solution. Oh well, let's try again. This time we have negative 1. And our first step is we want to substitute it in. So we're going to rewrite it again. 2x plus 1 is greater than negative 3. And we're going to substitute. If we take x is negative 1, will this be true? Is it true that 2 times negative 1 plus 1 is greater than negative 3? Well, let's find out. Let's simplify. 2 times negative 1 is negative 2 plus 1. Is it greater than negative 3? I don't know. Negative 2 plus 1 is negative 1. And negative 1 is greater than negative 3. Yeah, we did it. So yes, by plugging in negative 1, this makes the equality true. Yay! Okay. That's great, but that's only one of them. In fact, this inequality has infinitely many solutions. So how could we possibly take the time to list all the solutions? Well, I have better things to do with my time. So instead, we can represent them with a graph. So to graph all the solutions of an inequality, you're going to shade all the numbers on a number line. So first, what we have to do is we have to actually make a number line. So go ahead and draw your best number line right here and make sure that your tick marks are evenly spread out. We look at the number we're dealing with, 1, and I like to put that right in the middle. And then do like 2 or 3 numbers to one side. So 1, 2, 3, 4. And then keeping that same spacing, you want to bring that to the other side as well. So there, there. So 1, 2, 3, 4, and going the other way is 0, negative 1, negative 2. Now, after we just create our number line, in fact, now that we have a nice looking number line, I'm just going to use it down here for the next few problems real quick, if that's okay with you guys. Excellent. And now I need to take my variable and plug in some numbers and see if that makes it true. So let's start right over here. Is negative 2 less than 1? Yes, it is. So I'm going to mark that one. Okay, what about negative 1? Is negative 1 less than 1? Yes, it is. Great. And so is 0. But 1 is not less than 1. 1 is equal to 1. But a half, that's less than 1. And so is negative 2.5. So it's all of these numbers here. These are all going to work, but not 1 itself. So since we're going very close to 1, but not including 1, we're going to put an open circle on it. And because this goes forever, we're going to create this into an arrow. So there we go. We have a graph that represents n is less than 1. Some people might say, hey, you need to label this blueness. You need to label that as n. I'm not picky about that, but we can if you want to label it. Okay, for our next one, we have negative 3. So let's go ahead and put negative 3 in the middle of our graph and then add some numbers around it. So we have negative 3 going higher, negative 2, negative 1, 0, negative 4, negative 5, negative 6. Okay. Does it really matter what numbers you put down here? No, as long as they're evenly spaced. So if we wanted to just go with like odd numbers, we could go negative 3, negative 1, 1, 3, and then negative 3, negative 5, negative 7, negative 9. It really doesn't matter. And that's totally fine. You could also label every other one if you wanted to. That makes your graph look better. That's great. Okay, anyway, so let's plug in some numbers. We want to find out where does f, for what values of f is f greater than -3? Well, 1 is greater than -3, and so is 3, and -1, and so it's everything on this side. So we're going to cover all these numbers right here, shade them all in. We've got our arrow going that way. Excellent. By the way, some people say their like technique to this is they just have the arrow above the number line, and I'm okay with that too. You can have your arrow above the number line. And again, we're going up to -3, but not including it, so we have an open circle again. Those are all of our f's. And last one, we have -2. So let's label -2. It doesn't have to be exactly in the center. It could be like down here if we wanted to. We could do, could spaz. And then we could do like -2, -1, 0, 1, 2, -3, -4, like that. That's fine. And now we need to shade in some numbers for some values of a, where where -2 is greater than or equal to a. Well, is -2 greater than or equal to -4? Yes, it is. Is -2 greater than or equal to -2? Yeah, it's equal to -2, so that counts. Is -2 greater than or equal to 0? No, it's not. But look, -2 counted, so we're going to include that in our count. That's a solid circle going down. So that's my tried and true method, is always substitute, always plug it in. Okay, well, now let's go the other way. What inequality represents each of these graphs? Well, look at where your graph starts. Look at where your dot is. Here our dot is at -1. So we're going to know that -1 is important. We also need to pick a variable. They didn't tell us which one to pick here, so we can pick whichever one we want. How about we go with like K? K for Katarina. So we know that K is related to -1 somehow. And when we look at these numbers here, we have 1, and that's greater than -1, and 0, that's greater than -1. So it's going to be a greater than guy. But also look at our dot. It's shaded. So this includes -1. So that's equal to. K is greater than or equal to -1. Ta-da! Now this one. Our number here that's important is 4. So we know that 4 is important. And 2 is less than 4. 3 is less than 4. Or you could say 4 is greater than 3. 4 is greater than 2. So 4 is going to be greater. Oh, we didn't pick a variable. How about A for Antonio? Okay, yeah, A. So we have 4 is greater than A. But it's not equal to because we didn't include 4 here. So it's a strictly greater than. We say it's strictly. You do not have to know this by all means. By any means, I mean. So we say 4 is strictly greater than A. There you have it. Oh, final answer. Circled. Nailed it. Okay. Now that's great, Miss Van Dyke, but when are we going to use this in real life? Well, I'll tell you right now. So let's say that we need an inequality to represent the situation. The first thing we need to do is we need to define a variable. We need to say what our variable represents. So if we need to represent horse rides starting at $19.99, how about H? So here H is going to be the price of a horse ride. And look at your, that's ride with an E. And look at our units. So the price of a horse ride in dollars. So we have H somehow relating to $19.99. But how does it relate is the big question. Well, we say they start at $19.99. So they're equal to. But then if they start at $19.99, they can go higher. So you could have a horse ride that's $30. You could have a horse ride that's $100. Maybe it's like an exquisite horse or something. So that means h is always going to be bigger than, it's going to be greater than 1999. Or maybe they start at 1999 because you add tax and extra stuff to them. Now, here we have the speed limit is 8 miles an hour. So let's let our variable be s for speed. So let s represent speed in miles per hour. Okay? Then we know our s is going to somehow relate to 8. Relate to 8. That was not intentional. But the limit is 8 miles an hour, which is very slow, but you cannot go faster. You always have to be less than 8. You cannot exceed, there you go, that's better. You cannot exceed 8 miles an hour. So it's always going to be smaller than, greater than 8. Can you go 8 miles an hour if the limit is 8 miles an hour? I think so. So I think that should be an equals. So s is less than or equal to 8. Notice in example 5 that the variable was always to the left of the relation. It was always to the left of the greater than or less than symbol. That's not a requirement at all. Up here, the variable was, is on the left, but then it's on the right. It really does not matter, you guys. It's usually easier to read if it's on the left, but it does not matter at all. So in sum, we have 4 phrases that we talked about. We talked about is less than. We talked about is greater than. We talked about is less than or equal to. And we talked about is greater than or equal to. And here's your summary of the day. If you have, for example, x is less than 5, then that's going to look like x is less than 5. Like that. And then on a number line, this is just going to be a sketch. Oh, you guys, I'm about to sneeze. I'm so sorry. I'm going to sneeze. And I'm recording. I'm so sorry. Okay. That was super exciting. Now you're really paying attention. I usually try to hold it in, but there we go. We were so close. We're almost there. All right, anyway. So if x is less than 5, that gives us an open circle going to the left. However, we're just going to deal with x and 5 this whole time. So let me get that down there. If x is greater than 5, then we flip the sign around the other way. X is greater than 5, so I've got an open circle at 5. And it will be all the numbers greater than 5. However, if x is less than or equal to 5, then x is less than or equal to 5. So that's a solid circle, but still less than. And then if x is greater than or equal to 5, then that's this other way. It's a solid circle going to the right. So here you have it. Here is our key idea of the day. Know it, love it. This is how to graph. It's fantastic. If you have any questions, please let me know in the comments. Like, subscribe. Just kidding. And have a fantastic time on your homework.